Good afternoon, everybody. Hope everybody is well. All right, I'm in the module, and right after you should have a link to protein synthesis codon practice. So you want to download that worksheet, please, and then we'll talk about it in a minute. All right. Progress reports went out. Some letters just went out. If you were not passing, so if that's you, you need to make sure that you get caught up. Somebody at your house is going to pull your coat, say, why am I getting letters from your teacher while you're not doing your work? If you're borderline, I kind of spared you a little bit, but you got until tomorrow to make that well. Some of you are just missing one assignment. I have great faith in you that you will make that better. All right, again, good afternoon, good afternoon. Again, we are back live streaming again, so I will be putting the live streams on the playlist and the videos on the playlist again. Hopefully we won't get cut off again. All right, so again, go into Canvas in the module. So this is right after, come on, change pages. This is right after the diagram for, now this is, some of you are missing this. So we're going to be talking about how to use this chart today. So I put this in here because it's big. It's not on the worksheet. So this is just a reference page on this one. So last class, we talked about DNA replication and the fact that that the DNA never leaves the nucleus. So, but it has to give instructions on how to make a protein. So that information is then transcribed. And then that message leaves the nucleus and goes to the ribosome. And in going through the ribosome, while these are long strands, I tell you, think of these as like a ticker tape. And we're going to send this ticker tape through this conveyor belt. So the ribosome is like the conveyor belt. And as it goes through, it reads each of those bases 3 at a time. So that's what we're going to talk about today. All right, then the last picture up top shows you that the transfer RNAs bring the amino acids to the conveyor belt. It reads what the conveyor belt wants, and it goes and gets it. And then all of the amino acids that are attached to it attach to each other. And then the transfer RNA goes away and leaves the chain of amino acids to form a protein. So again, think of a protein as a string of pearls, and each pearl is an amino acid. And then once it's finished making that string of pearls, then it stops. And then the transfer RNA goes off and seeks some more amino acids. So what we're going to look at today, and don't worry about that link there. It may not work for you, but I did put the link in. Hold on, let me make sure that that's going to work for you. I did put it, actually, now that we have a playlist back in action. If you go to, there we go. That's it. So I put both videos on your playlist. Protein synthesis and DNA replication are now on your playlist, so you can watch those back. All right. Okay, so again, we are going to look at, let's see, we're waiting for everybody to come in. One more. All right, so we're doing the one protein synthesis and codon practice. So you're going to download this worksheet. And I'm going to go through I'm going to show you how to use the chart, but I'm going to do the first couple of questions with you. So when you send it to me, there should be no reason why. One, it should be no reason why you can't finish this today. And two, I'm going to go through the first ones for you in each section to get you started. Okay? All right, so up here at the top is just a general review of what protein synthesis is. So it's a process where a sequence of DNA is used to build up a protein from individual amino acids. Okay, so again, think of a protein as a long chain of pearls, and each bead on that chain is an amino acid. Okay, so that's what we're going to do. We have to find a way to find the amino acids and link them together to make this chain of proteins. So that's what we're going to be doing. All right. So the first step that happens in the nucleus is transcription. There's DNA opens up, so we showed that the DNA unzips, and then the messenger RNA reads the open side of the DNA and makes a copy of itself. So think of this as making a mirror copy. So it's reversed, okay? So the messenger RNA is a reverse copy of what the DNA wants to convey. Then it goes from it goes to base pairing. So remember that G goes with C and A goes with U because we're making RNA now. So every time there's an A, we're going to get a U, not a T. Okay, so the RNA strand is going to be AU and GC. Okay, and then it's going to read it in sets of 3. So we call this a triplet codon. All right, so we got some vocabulary here. We got transcription and we got codon. All right, once you have this set of 3, then we're going to go to the ribosome. And then it's going, and again, think of the ribosome as a little factory but the messenger RNA is going to go in like a tape. And while it goes through, it's going to read those nucleotides 3 at a time, 3 at a time. Okay. All right. And then we're going to use our chart to figure out what amino acid it wants to code for. All right, so this is where you got to pay attention because I'm giving you the answers. Okay, so we're going to walk through this. I'm giving you the answer. You're going to type it on your answer page. I'm going to do half of them for you. You're going to do the other half. All right. The way to read this chart, notice each chart, one side says first base in codon. At the top, it says second base in codon. And then on the other side, it says third base in codon. Because again, each of these is done in sets of 3. A codon is a triplet code. All right, so we're going to use this chart down here. Now, up in the chart, they're only giving you the abbreviations of the names of the amino acids. So there's 3 letters to abbreviate, but they really have long names. All right, so we're going to use the box chart first, and then I'll show you how to use the circle one. It really is the same thing. So we're looking at the first one, and it says CCC. All right, so that means the first letter is C. So we're going to look on the side that says first letter in the base and find the one that's C, and that's our second row. That's the orange box. All right, so we know that our protein is going to be found, our amino acid is going to be found in the second row. All right, then we go up to the top, second base. Second base is also a C, so that's, we know that we're going to find the C, we're going to come down to the second row, so we know somewhere in that box, on the second row, second column, is the answer to our problem. Third letter is C, so we're going to follow along the line for C, and we're going to see CCC in that box. And that tells us that the amino acid that we're looking for is proline. It's abbreviated PRO. So that's the word you're going to write on the line. You're going to write PRO on the line. All right, let me let this last slate person in. All right, up 2 people. 1 second, I'm going to have to back up a little bit. All right, and folks, y'all need to be on camera. Some of y'all just, like I said, laid back and not on camera. We had an observer the other day and they noticed that you weren't on camera, and you are supposed to be. School rules, be on camera.
I'm sorry, I was cleaning up a mess that I made while trying to clean the dishes before getting my lunch ready.
Well, you weren't the culprit. Some people have no camera on. I at least see your room. All right, Troy, Talacia, Brandon. Y'all come late. Turn your cameras on. Turn your camera. Troy, I don't even know what you look like because you'll never turn your camera on. All right. All right, for the latecomers, we are in the module. If you look in the module, download the worksheet that says protein synthesis and code practice. I'm going through the first couple of answers with you to show you how to use a code reading box. All right, we already read the top, so just follow along, please. All right, so I'll do the first one again. Our triplet code is CCC. So we want to go up to the box, and it says first base in codon is C. So we find that in the orange box, and that tells us that our answer is going to be in the second row. We go to the second base is also a C. So that tells us that it's in the second row, second column. And then the third side is also C. So we run our finger over and we see CCC in the box. In this case, and we just heard this in the video, that sometimes there can be more than one way to get the same amino acid. That is the case with this proline. Okay, there's 4 different ways to get proline as an amino acid, but so you're going to write the word P. It's okay if you write PRO on the line. It does have a long name, but for right now, just write PRO. In the next one, it'll tell you how to spell it. Okay, but that's the name of that amino acid is proline. So you're going to write PRO on the line. I'm going to go down. So the next one I'm going to do for you is CAG. All right, so we do the same thing. The first letter is C. So on the first where it says first base, that's C. That's the orange box. Second base is A. So we go up to the top. And that's the A is the green. So that tells us it's in the second row, third column. And our last one is G. So we come down, the G is the last row in that section. You're going to see CAG and the abbreviation GIN. So you're going to write GIN on the line. And notice in this case, there's 2 ways to make that amino acid. Okay. Everybody follow? Anybody want me to stop and repeat? Okay. Next one. Like I said, I'm going to do the first column. You're going to do the second column. And then I'm going to show you how to do it in reverse. Actually, I'm going to show you how to use the circle to do the same thing. So the third one is GAA. So G is the first one. So that's the blue box on the first side. The second letter is A. So we go up to the top and we see that's the green one. So we come all the way down. So we know it's the 4th row, 3rd box. And the last letter is also A. So we look for GAA in that box. And again, you could use the third row, but technically you could just find the one you're looking. Once you've got the first two done, you can just look in the box to see where it is. So GAA is glucine. So just write GLU on the line next to that. That is the name of the amino acid. All right, the last one I'm going to do for you is UUU. All right, so U is up at the top, and then U is in the second box. I mean, the first, so it's the first box on the first side. It's also the first box, the purple one, on the second. So then we want to come down, and it's going to be the first amino acid in that box as well. So that's going to be I think that's, how do you pronounce that one? That's going to be phenylalanine. Phenylalanine is the name of that one. But you can just write PHE on the line for this one. Okay? Everybody follow? All right, so like I said, I don't want any blank worksheets because I did the whole first column for you. You only have to do the second one. All right, let me show you how to do the wheel. The wheel is the same, except you're going to start in the middle and work your way out. So again, with our CCC, we're going to find C, and that's the pi piece in the right lower segment. So that means everything that we need is in that right segment. Okay, then we come to the second circle, and our letter was C again. So that's going to take us to the Brown's wedge in the third row. And again, it's going to be proline. Okay. So it kind of goes the same way, except you start from the middle and you move your way out. Now you need to know how to use both because it depends on who's writing the test, whether they will give you the circle or the square. I prefer the square, so I'm going to give you a square. Okay, I find the square easier to navigate. All right, so that's that one. Now they want you to do it in reverse. Okay, so they've given you the name of the amino acid. They want you to write all of the codons that can code for proline. So we go back to our box and we find our PRO. Notice it also highlights the first three letters. Even though they've given you the whole name, they've highlighted the first three letters because that's what's in the chart. So we come back up here to the chart and we find our PRO. And then we find that there are 4 different codons. So you're going to write all 4 codons on the line here, because there's 4 different ways to get that amino acid. Okay, don't leave off any, because I'll take a point off. All right, the second one is valine, abbreviated VAL. So I come up to the chart and I look for VAL, and that's in our box down here. First row, last row, first column, VAL. And again, there are 4 different ways to get an amino acid of valine. So you write all 4 of those on the line for valine. And then the last one that I'm going to do with you is histidine. So you're going to come up here, find the HIS, and in this case, it's in the second row, third column. In this case, there's only 2. There's 2 codons for that amino acid. So you only have to write the 2 on the line. Again, I did the first column, you're going to do the second column. All right, I'm going to let you, and I'm going to tell you this one too. Locate on the chart, there are 3, the start codon. So it actually says start right there in yellow. The yellow one is your start. It does the same thing on the circle too, except they didn't, it tells you what it is. It's not highlighted in a color, but it's the same. So AUG is your start codon. It'll be the same AUG on the circle as well. And then there's a stop codon. There's 3 different ways to stop this protein from. So all proteins are going to start with AUG because that's indicating this is where we need to start from. But there's three different ways you can tell it to stop. So you want to make sure that you write all three of those. All right. Then what you have to do over here, you have to translate this. Okay, so the DNA gives you this triplet at the top. You have to write the RNA strand, and then you have to write down, go back to the chart and figure out what protein goes with that triplet code. Okay, and actually this should be, it should be 2 rows because you want, and we're going to leave it like this. There's a flaw to this, but because when the messenger RNA copies the DNA, it makes a reverse copy. Then the transfer in our RNA brings in the actual copy. So it gives it back the mirror image. But it's going to be all right though. You'll get we simply want you, and they've already divided it up into threes. So you're going to put underneath it the 3 codes. And remember, first strand is DNA. There is no T in RNA. It's going to be U. So when you do the second row, all of those should say U where there's a T. And then you're going to take that message, that triplet code, and you're going to come back up to the chart and figure out what amino acid is that coding for. Okay, so you're going to do that 3 times. All right, I'm going to stop talking. Any questions? Any questions? All right, so note that there are 3 codons to stop. There's only 1 codon to start. All right, I'm going to stop sharing so I can do attendance. Again, everybody should be able to finish this today. This should not be in the late assignment. If your body is here, I expect to see this assignment in the box today. If you finish this early, please, and you owe something, please work on any missing assignments you may have. I repeat, if your body is in the room today, and this is not in my box today, you're late. Okay, where did she go? And folks, y'all can't be logging in and then disappearing halfway through class. To me, that's an absent. Good afternoon, Jayla. You need to go in your module and download the worksheet. Excuse me. It says protein synthesis and code practice. As soon as I finish attendance, I'll help you with that. See if that omega come back. Actually, let me check something. And I repeat, if this worksheet isn't in and your body's in class, that's a 0. Jayla, you looks like you're having trouble logging in. Because now I got you up here twice. Okay. Still got you up here twice, but I see you now. All right, so Jayla, go to the module and you want to download the worksheet that says protein synthesis and code practice. I'm going to walk you through how to do the first 2 questions, and I'm going to leave you to answer the rest. All right, take a minute to read the paragraph at the top. All right, and if there is anybody else who was slightly confused, I'm repeating everything all over again. All right, so we are trying to make a string of protein. Protein. Yeah, you can write the full name if you want to. That's fine. Okay. All right, so Jayla, you got your worksheet up? Okay, so let me go back for a minute for you. Actually, kind of come out of that. Go back. All right, so if you look at the previous lesson in the module, you have a picture of what's going on. So the first thing that you got to do is make a copy of the DNA. So the RNA is going to go along the open strand of DNA and it's going to make a copy. So it's going to have, there's going to be loose nucleotides floating around and it's going to link them together to make a copy of the DNA. Then it leaves the DNA. So we have transcribed the DNA. Then that strand, I'm in the middle picture now, that strand of copied DNA is now an RNA strand. It leaves the nucleus, it goes to the ribosome, and in the ribosome, it's going to read the message. We're going to translate the message. So it's going to go through the little protein factory called the ribosome, and the transfer RNA is going to read that information and it's going to go and get the amino acid that it's telling it to get. Those are those little dots on the end. So the squiggly looking thing that looks like an upside down T is the transfer RNA. On the end of a transfer RNA, there is because there's only 3 codes on the transfer RNA. So at the end of each transfer RNA, there's an amino acid unique to that triplet code. So they bring it to the strand, they line them up, and they connect. And then the transfer RNA goes away and gets another amino acid and comes back. On number 5 for RNA, the thing. Jocelyn, come off mic and tell me what it is you're trying to say because I'm not understanding what you just typed. Unmute.
For number 5, how do we figure out the RNA in the second thing?
Okay. So coming back. All right, for number 5. You see those 3 letters there? You need to find the complementary letter. All right, folks, I'm going to do the first one for you. So everybody pay attention. Number 5. It says TAC. All right. RNA, I said RNA does not have T's. So actually, okay, let me back that up. The RNA does not have T, but it does have an A. Okay, so the first one, T, is always going to be complementary with A. So the first letter on that is going to be A. And A is going to complement with U. And C is going to complement with G. So that first triplet is going to be AUG. That's what you have for RNA. So then you're going to run up here to the chart and you're going to find A, go first one is the green one, U is the purple, and G is the last one on the bottom. So that first amino acid is leucine. Okay? All right, and Jayla, I got ahead of myself with you, but this is how you read the box. Whatever the letters are, you take those 3 at a time. It says first base, second base, third base, and so you go around and you find it like that. So again, this one that we just did for number 5 was TAC. The complement to that is AUG because A normally, if this was DNA, A would be T, but it's RNA, so it's got to be a U. Okay, so on that row for RNA, you don't want to see any T's. Every time you see an A in the DNA, you're going to have a U. And you need to do that for all. So there's 1, 2, 3, 4, 5 sets of 3. So you're going to line up 3 amino acids in a row. Okay, you're going to make a triplet code, 5 triplet codes of RNA. You're going to find 5 amino acids. Same thing with the second one, 2, 3, 4, 5. So yeah, each of them has 5. The complement to G is C. And y'all need to write that down because I told you that before when we were doing DNA. You must know that G is the complement for C on both RNA and DNA. A is the complement for T on the DNA strand, but A is the complement to U on a RNA strand because there is no thymine in RNA. Okay, that was why it was important that you all labeled all of the diagram when you did your DNA so that you would know who complements who. They looked like puzzle pieces for a reason. They fit together. So if you forget, go back and look at your puzzle diagram so that you know who matches who. Okay, any other questions? Any other questions? All right, Jayla, back to you. So at the top, you're going to read the chart and you're going to write the name of the amino acid on the line. On the second one, they've given you the amino acid. You have to go back up and find all the codons that code for that amino acid. Okay? So for example, proline, if we go back up to the top, proline is in a box in the we did that with the first one. The first one was CCC, and it took us to the second row, second column. And if you notice, there are 4 different ways to get a proline amino acid. So on this line, you've got to write all 4 of them. Yes, CCC is proline. So that's what, so you're going to write proline up here on the first one. Well, down here for proline, you're going to write all 4 of those because proline can be CCU, it can be CCC, it can be CCA, or it can be CCG. So on the second one, they want to know the names of the codons that code. So some of them have 3, some of them have 2, some of them have 4. All right. Everybody good? And I repeat, if your body is in the room today, the worksheet needs to be in the folder today because this doesn't take all day. This is a very short assignment.
Miss, on the slide 2 of the protein synthesis and Condine's practice on question 5, how do I do those?
Okay, that's the one I just explained. All right, give me a second because I was actually trying to save the video. So folks, we're back in business. I can save the lessons now. So again, if you truly are confused, you can go back and watch the video this time. But I'm going to help you right now. Just give me 1 second to um, and I need everybody to listen. Somebody asked this question earlier, so I need everybody to listen because some of y'all are up to number 5 now. And give me. Okay. Let me pull that back up. All right, so again, those letters are in sets of 3. So first thing you have to do is the first row that you see on the page is a DNA strand. So you have to create an RNA strand. Okay. So, and they've divided it up in 3. They've separated them so that you don't have to separate them. But that's not how it normally is. Normally, they're all linked together and you would have to go and group them in sets of 3. But they did that for you. All right. So the first set is TAC. So the strand that you want to write for TAC is the complement. And you write the complement of T is A, because we do have an A in RNA. However, the complement of A is U because there is no T in RNA. And then the complement of C is G. All right, so now you have a molecule that is AUG. So you go back up to your chart and you find A, U, and G, and that's leucine. So then on the row where it says amino acid, you write leucine. And you do that for each set of 3. So you need to complement CAT, you need to complement GGA, complement ATT, complement ACTs. And when you create that complement, then you go up and look for the amino acid for that set. All right, that makes sense? Everybody got that? And you're going to do that for all 3 of these. Now, this is just a sample. In real DNA, the molecule could be 100 beads long for one gene. This is coding for one thing. They're just giving you a sample for you to practice.
Another question. How do you find out what's like what links with the other letters?
You should have that written down somewhere. All right, remember back when we, hold on. And again, folks, you should write it down, commit it to memory. Commit it to memory. Let me go back again. When we did the worksheet that y'all did earlier, this is why it was important. And even if you color coded it, you should still, not that one. We have so many worksheets. I'm getting there. Come on. It's the one before this. Oh, actually, I told you right there, though. All right, the reason we did this was so that you would know. And they look like puzzle pieces because they are complements of each other. So every time you have an A, you have a T. And every time you have a G, you would have a C. And they fit into each other. That's why they're drawn like puzzle pieces, because they fit together. The other A's don't fit C's and G's don't fit T's. Okay, this is a rule. A is always going to complement T, and G is always going to complement C, except when it becomes RNA. A is going to complement U. All right, and I believe that it is right here. Okay, A pairs up with thymine, cytosine pairs up with guanine, and that's on DNA. And they tell you again on the next page, if we're making RNA. So write it down somewhere, make a note. No, it doesn't tell you, but somewhere in the practice thing, they tell you that you will always have a U. There are no T's in RNA. All right, again, notice in this box, there are no T's. You have U's, but no T's. Because these amino acids are made from RNA. So transfer RNA can only bring a U, not a T. So again, write it down somewhere. DNA is CG and AT, and RNA is CG and UA. They complement each other. And actually it says it up here in the top. Thiamine, it's instead of uracil. And again, write it down somewhere because this is only the beginning. We got a whole lot more DNA and RNA to do. We have to talk about mutations. So you're going to have a practice where sometimes you're going to see a mutation. You actually have those diagrams in Canvas, except they're so small. You can hardly see that, but it does explain how to use the codon wheel or the codon table. So next we're going to talk about mutations. Okay. And remember with these second question, if there are more than one way to get that amino acid, you must write all the ways. If there's 4 ways, and you need 4 codons, then you need 4 codons. Some have 2. The stop codon, there's 3 different ways to stop, 1 way to start. Again, remember, T can code to A, but A has to code to U for an RNA. All right, 10 minutes left to class, and I only see 4 people submit. Okay. Don't forget, if you owe anything outstanding, use this time, because anything else is late. Mm-hmm. Three. Yeah, number 3 only has 1. You only have 1 way to start the protein process, but there's 3 ways to stop it. All right, folks, it's time to go. So please make sure you get this turned in today. Keep working on it. And I'll see you all on Monday. So it's Monday. We'll talk about this some more, and we'll talk about mutations. What happens when you don't read this properly.